Specific heat capacity is an important concept in thermodynamics. We're going to explore what specific heat capacity is and what impacts it may have on experiments involving calorimetry in this video. To start, we're going to explore what is specific heat capacity. So specific heat capacity is the energy required to heat 1 gram of a substance by 1 degree Celsius. In a mathematical formula, we will be representing specific heat capacity with the letter C, so a lowercase c, and we will be giving it the units joules per gram degrees Celsius or kilojoules per kilogram degrees Celsius. So we're going to be using this first one, joules per gram degrees Celsius, when our mass is measured in grams. We're going to be using the second one, kilojoules per kilogram degrees Celsius, when our mass is measured in kilograms. By examining the units of specific heat capacity, we can see that these units are an energy term. So kilojoules or joules is a term of energy divided by a term of mass, so grams or kilograms, multiplied by a term relating to temperature. So the energy required to increase 1 gram of a substance by 1 degree Celsius. So all of the parts of the definition are found in this formula. We're going to explore now how the magnitude of our specific heat capacity can impact the temperature change of a substance. And we're going to do this by comparing two substances of equal mass. So in this beaker, we have water, and we have 100 grams of it. Water has a specific heat capacity of 4.19 joules per gram degrees Celsius. This key is made of copper, and it weighs 100 grams as well. It's an old-timey heavy key. Copper has a specific heat capacity of 0.385 joules per gram degrees Celsius. So the specific heat capacity of copper is significantly lower than that of water, more than 10 times lower. If we were to heat both of these substances by providing an equal amount of energy, so I'm drawing fire here in case you couldn't tell. So if we provided equal amounts of energy to both of these substances, and they have equal mass, what we will see is that their temperature changes are not equal. So if equal amounts of energy are provided to equal masses of these objects, copper will experience a higher temperature change. So if water's temperature increased by 5 degrees Celsius, we would expect the temperature of copper to increase by approximately 50 degrees Celsius if the same energy input was given to both.